first 5 days will be the integral from 0 to 5 from 20 e to t dt. So this is 20 e to t from 0 to 5. Now, was this something that you had difficulties with, or do I need to explain any of this, or?
I think I got that part. It was just B that I sort of struggled with.
Okay, it says find the sales from the 2nd day through the 5th day. So the integral from, is it 2 to 5? Is that what you had difficulties with?
Yes.
If we want to, so for this particular situation, we should start with 1 through 5, and here's why. The same thing here on the first day, right? On 0 day, I don't sell anything, but the sale starts on the first day, not the 0. So here, if we want to include from 2 to 5, then we basically have to start with 1, from 1 to 5.
The book actually says, like, for part B,
does it?
In parentheses, it says this is the integral from 1 to 5.
Okay. So from 20 e to t dt. So this is 20, the integral from e to t dt, which you know, I don't have to write this intermediate step, e to t from 1 to 5. So remember what we do, we plug in 5, so this is e to the 5th power minus e to the 1st power. And I have my calculator up here, because I had a session with a stat student. So we were doing the normal distribution earlier. So then you plug in 20, and we have E. I didn't calculate anything yet, minus E. So this is the E, single E right here. And the one with the power is right here with natural log. So I got 2913.89 or 0.90. So 2913.90. Good, very good question. Anything else? Other questions here?
It differs from 0 because when you input 0, it's a different number than the first integral.
So you're talking about
that's the difference between the two, between A and B, is because in A.
So in A, it says for the first 5 days. Mm-hmm. So first 5 days, it's from 0 to 5. So for the day from day 2 to day 5 is the integral from 1 to 5. So this one basically was 1 through 5. So I have to start at 0. And this one is 2 to 5. So I have to start at 1.
Okay.
Good. Anything else? Other questions? Anything in my lab math?
Yes, I had a.
I'm ready. Yes.
The problem was the integral from A to B of t to the 4th minus 3t all over t to the 3rd dt.
Perfect. In this class, we have many techniques of integration, as I mentioned. In this class, however, we will not differentiate a ratio. So you have to separate it, as we know from algebra, only because the denominator is one term. If you have 2 terms or more, you cannot do this. So the function becomes t minus 3 divided by t squared. So t to the 4th over 3, t to the 3rd is here, and simplified by 1t, and we get this. So I will rewrite it as t minus 3t to negative 2. So then I will continue on the next page. Is this okay so far? Okay. So then I have the integral from a to b from t minus 3t to negative 2 dt. So this will be t squared over 2 minus 3. T to negative 2 plus 1 over negative 2 plus 1 from a to b. So I will clean it up a little bit. So plus 3 over t. Negative 3 with negative 1, I get positive, and 1 over t from a to b. So I plug in b, which is b squared over 2 plus 3 over b, and minus when I plug in a squared over 2 minus 3 over a. Now, I don't know, I can find the least common denominator and just try to massage it a little bit. So 2ab. So this one needs an ab, like this one needs an ab, and this one needs a 2a, and this one needs a 2b. I don't know if that's really needed, but okay, I started it, so I have ab cubed plus 6a minus a cubed b minus 6b. Yeah, I could factor, but what's the point? There's a 2ab in the denominator, so. Is this what we had? Good. Anything else? Other questions? Okay, so then I would like to continue now and talk about the next section, which is properties of definite integral. There are many properties. So this is 4.4. Well, we used many of them so far. Okay, so what did we use? Well, we listed several. So we listed that the integral from f of x plus or minus g of x dx is the same with the integral from f of x dx, of course, plus or minus the integral from g of x dx. We listed that a long time ago. Then, yes, of course, we're talking about definite, but it doesn't matter. It's the same. So here's another one. So the integral from a to b, we used it already. F of x dx. C goes in front as a factor, like for the limits, like for the derivatives, everything like that. So the constant goes in front. And there are many inequalities, but they're not in your book. We talk about them in another class. So they're not required for this class, but I present them in my other calculus classes, the one for STEM majors. So here's another very important one. So let's talk about this one. So let's say I have a function f of x, and I have a, b, and c. So this is the area between a and b under the graph, and this is the area between b and c. And the integral from a to c from f of x dx can be split into two integrals. From a to b from f of x dx, plus from b to c from f of x dx. You can be fancy and say, okay, the integral from a to c is, or the integral, let's say, from b to c is the integral from a to c minus the integral from a to b. Or the integral from a to b is the integral from a to c minus the integral. So you can play with this as you please. Okay. The other thing is if we have a function, given a function, we can determine the function average. So average value on a particular interval, on a comma b, it's b minus a, the integral from a to b from f of x dx. Okay, so we can always determine on a particular interval, we can determine the average value of a function. How? In front, 1 over b minus a, the integral from a to b from f of x dx. And the other thing that I wanted to say before we practice all these, for example, Let's suppose I have two graphs. Here's one, and this is f of x. And here's the other, and let's say this is g of x. And let's suppose we're asked to determine the area enclosed by these two graphs. Of course, I have to find the points of intersection. Let's say this is A and this is B. So this area, I'm going to call it A. So how do I determine the area? Is the integral from A to B from the upper function minus the lower function, f of x dx. How come? Sure. So it's this area minus this area. And it's exactly what I'm interested in. So the area under the graph that is above minus the area under the graph that is below will give us the area that is enclosed by the two functions. And now I would like to first practice this, and then the average value, and then properties and word problems. And then I'd like to talk about the substitution rule. And that will be the end of chapter 4. So I want to be on 412. So we can look at the absolute value, these problems. I think this is a little bit beyond the scope of the course, but let's choose an absolute value if you'd like, only because we haven't talked about the absolute value a lot, but we talked about piecewise defined function, and that's what the absolute value is. So we can start by finding the area under the graph, and this is an application of the property that we just discussed. That's one. Then we can look at an absolute value. And then I would like to continue with determining the areas enclosed by graphs. But yes, these are very fun and nice when the graph is given, but I'd like us to choose something with a graph when the graph is not given, and we need to come up with a graph. So these are the first 3 steps. So let's start. Which one? Or I will choose.
Can we do number 2?
Okay, so let's take a look at number 2. Here it is. Good. I'm on page 4. Okay, so we have f of x. That's 2 on page 412. F of x equals x plus 5 for less than or equal to 4, and 11 minus 1/2 x for x greater than 4, and the interval is given to us in the problem as 1, 5. So all this means is exactly what we just talked about. So this is 1 to 5, 1 to 5. And there is a break in the middle with a 4. So I have to find the integral from 1 to 4 from x plus 5 plus the integral from 4 to 5 from this. That's it. So the area is the integral from, I have to stop at the break, right? That's where the break is. The integral from 1 to 4 from this, because this is less than 4, plus the integral from 4 to 5 from this. 11 minus 1/2 x dx. All I have to do is just calculate. So this is x squared over 2 plus 5x, right? From 1 to 4, plus 11x minus x squared over 4 from 4 to 5. So the antiderivative of x is x squared over 2. The antiderivative of x is 5x. The antiderivative of 11 is 11x, and the antiderivative of x is x squared over 2, but x squared over 2 times 1/2 will be x squared over 4. So now, of course, these functions are continuous everywhere, so I didn't have to worry about that. So now I will plug in 4, and I get 16 divided by 2 plus 20, but minus 1/2 minus 5. When I plugged in 4, 16 divided by 2 is 8. 4 times 5 is 20, but minus when I plug in 1, 1/2 minus 5. Plus, now I plug in 5, and I get 55 minus 25 over 4 minus 44, but plus 16 divided by 4, which is 4. Always remember, when we plug in the top, minus when we plug in the denominator, the lower limit. Okay, so let's see. Okay, I see a 28. I see a 50. And I see minus 40. So this is 78. And minus 40 will be 34, right? I'm sorry, this is negative 40, so it will be 38. So 38 with these already. And this is negative 1/2. So this needs a 2. So negative 2 minus 25, minus 27 over 4. So this will be 4 times 38 minus 27 over 4, assuming I did not make any errors and assuming I find my calculator. I know that one is up already, but just for these minor calculations, I would like to, my calculator is right here. Okay, lazy people do those with the calculator, like me. 400 minus 27, and I cannot simplify. Okay, so 125 over 4. Okay. So that is the area under the graph that is given as a piecewise defined function between 1 and 5. Good pick.